Hi friends, welcome to the final topic of the Kubernetes today, and this will be end of that ultimate the crash course on the Kubernetes which I have started. Okay, and don't think this is the end of this Kubernetes. Okay, there are so many videos will come on the Kubernetes perspective. Okay, and this is the final for the crash course which I started for the Kubernetes, where the people who wants to take a certification and who wants to step into the Kubernetes world, right? So for them, this is the basic understanding for a beginners and for professionals also this will be helpful. Okay, and then let me go through the topics which are essential concepts for the Kubernetes. Let me increase the font. So as you know, in my previous topics on the Kubernetes, I have covered for the pods, replica sets, as you know, deployment services, volumes, config maps, secrets, and ingress. So you can see my previous recordings on all these topics. So what are the next topics to be covered in the Kubernetes to understand how that application deployments are happening, how we can make use of the existing manifest, existing API objects in Kubernetes to use further. Okay, what's next? So the main concept here is like the auto scaling in Kubernetes. So this is something little advanced topic in Kubernetes, but how that auto scaling is happening and what are the basic utilization, basic criteria to be considered when you want to do a auto scaling in Kubernetes. That means in Kubernetes there are two types. We have a horizontal pod autoscaler, that is HPA, and vertical pod autoscaler. So HPA and VPA, it will be decided on like first horizontal pod scaling will be in the CPU and the memory utilization perspective. So we need to put a constraint on these two areas, and based on these utilizations, the pods will be act accordingly. Okay, for example, I'll tell you one example. Like when you have set the pod count as 3, that is your maximum, and your minimum will be 1. So, and you already put a CPU and memory utilization to the pod, like there is some threshold you can put it accordingly based upon your traffic. Okay, that how you can decide it, as I said in my previous recordings, like the control manager will make sure how the desired replicas or actual replicas will be considered to maintain the availability of the pods. That means kube controller manager will keep on looking for the desired state to maintain the replicas. I mean pods. How that replica count will be managed is like what is the metric value we are setting up for the particular, sorry, what is the metric value we are setting up for the particular pod and desired metric value. When you run a pod, you will provide some CPU and memory utilization values. Based on those values only, your pod will be scale up, scale down. So technically speaking, horizontal pods autoscaler is like you want to increase your pod based upon the CPU and memory utilization. When there is any fluctuation happen with the desired state, the pods will get increased, and once that is recovered, it will come back to the desired state. So that is the meaning of this horizontal pod autoscaler. When we need to apply this horizontal, you already set, like for example, you already have a pod count some amount, and you can apply HPA for your the deployment. If you apply the HPA for your deployment, so when that percentage reaches, it is automatically scale up the pods and scale down accordingly. So that is the beauty of the horizontal pod autoscaler. This is the algorithm we have it for the. So based on the desired replicas only, the HPA will manage the pod count. So typically by applying HPA, we are restricting the pods to utilize the and provide a CPU memory limits to avoid the bottlenecks. So when it reaches, as you know, if you don't have HPA, what will happen? The CPUs and memory utilizations will reach the thresholds and the pod will go down, and there are so many issues will happen in the background, so that it will disrupt our live traffic also in production. So it's good to use horizontal pod autoscaler for your deployments. Vertical pod autoscaler is like how you can increase your node details. Like for example, resources, how much resources you are using for your cluster and nodes and etc. Based upon the request and limits you are applying for that nodes, it will get increased in the vertical. So horizontal, as I said, like it will be pod based, and if you go with the vertical pod autoscaler, it will be like a node level details and all. And cluster autoscaler, if you apply, it will be dynamically add your and remove the nodes. But this is having some problem when it comes into on-prem. Doing this dynamically will cause some disruption. Okay, and it will cause some it cannot take the traffic and it cannot increase the clusters dynamically on premises. It will, but it causes some disruption again. So it is mainly applicable for the cloud providers like AWS, Azure, and GK. You can apply this cluster autoscaler and it will increase the nodes dynamically. So this is about the auto scaling in the Kubernetes. So going to the next topic, resource quota is like you are applying this quota, like the certain amount of the limits you are applying for you have it, and you know these values are decided based upon the traffic you have for the respective application, and you can come out with like I have pods count of 10 and request CPU limit will be 4, and these values will be discussed, and you already decided and you created an example quota. The name of your resource quota is example quota. So when you apply this respective quota to any namespace, the applications, that means the pods which are getting deployed to this namespace will utilize this, and it will make sure the request limits are achieved or expected. So if it is having any modifications or any changes, the quota will not allow to exceed that one or to degrade that one. That means it will control the resource usage per namespace. So it's something like you have a namespace and you are allocating the resource quota for that namespace, and you are adding your application to that namespace to restrict that the namespace completely with your resource quota. Okay. So for example, like if you want to take an example for this one, it's like you have a hotel and you have the rooms and you are locking and you are keeping you I mean you are locking those rooms and you are booking those rooms for the single bedroom, double bedroom, something like that. You are separating that, okay, and keeping those keys with you. So you know the limits of that, like how many peoples will be available in this room, how many peoples can be set to this other room. So like that, the limits. Okay, maybe my example will be wrong, but from the technical perspective, a namespace or resource quota is mainly for you to apply a quota for your namespace and add your applications on top of the namespace. Okay, this is about the resource quotas. And next I'm going to the next topic is RBAC. Before going to start RBAC, first you need to understand about what is a service accounts are like. Rather than a human doing some activity, a service account will get created, and this service account will do the task what we are doing it as a human. For example, you have Argo CD, a deployment tool, and you have some Prometheus node exporter, anything. Okay. On the whole, you can deploying any agent in your Kubernetes cluster, how it is connecting to the cluster and scraping the data for Prometheus and sending the deployment details to the Argo CD console, how it is happening. So that's where the service accounts will get created for this Argo CD or Prometheus, different agents in the market right now. So what they will do when you run that the manifest provided by them, it will create the service accounts, cluster bindings, role bindings, etc. You will see the list of all the manifest required for this Argo CD, correct? So after installing that only the complete applications will come up, and you can see the deployment details or Prometheus metrics details, everything in the front end. So when you create a service account and you have to grant a role for that service account, like whether the resource has to list the pod and resource has to connect to the any other services again. So these things you have to, when you create a role, when you create a service account and you have a attached to a role, and the role will bind it to the service account, so that this is like a end-to-end communication. So this is like service account role binding. This has to happen in a parallel fashion, so that any application which is coming under this bound will work as expected. For example, in this screen, I'm showing here like there is a role I created for the name pod reader under the default namespace. So what it is doing, I am applying a role which will get and list the pods under the default namespace. And same thing in the left hand side, I'm showing the cluster role, a role. What is the difference between this? A role is particularly for any the service accounts what we are doing it for the application perspective. Cluster roles are like a cluster perspective. Okay, for this respective to this cluster, what are the activities we are going to do for this cluster? Okay, it's like a 100 feet top level what we are doing from the cluster activities, whatever, irrespective of the application, what are the activities we are doing it for the cluster level, those will come under this cluster role. Next, so hope you got it. I just want to tell about this like service account role and role bindings. and cluster roles are the cluster level perspective. Okay, next topic is network policies are something you are creating and you are restricting the traffic. That means, default we have the ingress connectivity and you can connect each pod. When you bring up any pods, number of pods, you can able to communicate the pods inside the cluster, that you might be aware of it. So how you can restrict that? As you know, when you have a three-tier architecture, the database pod will not expose to the external world. So the DB will be exposed to the internal application and web application. So how you can restrict that one? So using this ingress only, using this network policies only, you can stop the connectivity from the DB to expose to the external world and expose inside the internal cluster. Okay, this is the beauty of the network policies. In this example, I am creating a allow web, and whatever the pod selector, I am giving the match label as a app web, so that web only will have that ingress traffic. Okay, ingress means it is from to that respective pod. So whatever the pod selector I am giving there, that is having a connectivity from this web pod, which is having a label app colon web. So that is the connectivity of this network policies. I'll show you and I'll explain you in detail in the Kubernetes documentation itself. This is stateful sets and deployments. I will tell you a very small example between these two, like deployments. Where we have so many deployments we did for the Nginx, and when you create a deployment, you can come up with the different names for the pods. It will come with Nginx, XYZ, ABCD, colon 1, 2, 3, something like that. So even when you delete that pod, it will create a new pod name. Every time when you delete the pod, a new pod name will come. And at the same time, if you didn't attach your volumes, what will happen? The data will get deleted. So that is the reason we have the stateful sets, and this is mainly used for the database. When you have a database and you want to store that data as a persistent level, you can create your persistent volume and you can have your persistent volume claim, and you can create a stateful set. So even when you delete the pod, or even if it is happened by mistake, the pod, it will come up with the same name, so that the connectivity what we are making it from the web server to the DB connection, it won't disrupt. So that is the main use of this stateful sets. The main thing is the persistent of the storage, and at the same time the unique pod identities. So this is the beauty of. So finally, the troubleshooting of the Kubernetes. I will take you to the just a sec. Finally, I am come to a conclusion of the Kubernetes, and the basic commands of the kubectl logs, kubectl descript, those things I will provide in the description. And if you have any questions on this Kubernetes troubleshooting also, you are glad to add your questions in my comment section. I'll happy to answer on that one. And even if you have any advanced topic you want to understand from the Kubernetes side, please don't hesitate and please let me know in the comment section. And I just need a big thanks for the people who have subscribed to my channel, and I need your support to provide this type of content in future. Keep supporting. If you like this video, please like, share and subscribe to my channel. Thanks for watching.